Now let's take a look at problem 2 on the practice final. Okay, so it's just a problem about giving the average rate of change. So it's very easy. What are these? We don't need to know what the graphs of these functions are, but they're very pretty. And so I want to do kind of a little function beauty contest here and just show you the graph of each of these. So first function is sine x to the x, and you can see what these others are. So here are the pictures. Like I said, it doesn't much matter. But they're interesting shapes. So the one in black is sine x to the x. The one in red is natural log x squared plus e. Makes a nice little like ox horns shape. And this blue one is e to the x minus e to the minus x, which is similar to something called a hyperbolic trig function, which you might learn about in calculus next semester. Alright, so we can figure out the average rate of change without knowing how attractive those functions are, because there's just a very simple formula for the average rate of change, right? Average rate of change for any function between, like on an interval a to b, so let's say we have an interval from a to b, the formula is just f of b minus f of a over b minus a. And so all I have to do is apply this formula in these three cases. So let me do it one by one. So for a here, I've just got sine of pi to the pi minus sine of pi over 2 to the pi over 2. And on the bottom, what do I have? I have pi minus pi over 2. Alright, and so you know that sine of pi, since pi is sine is the y-coordinate, and over on the unit circle, pi is on the x-axis, so this is going to be 0 to the pi minus, what is this? This is sine of pi over 2 is 1, right? So 1 to the pi over 2. And pi minus pi over 2 is otherwise known as pi over 2. And so what is all this going to be? I'm pretty clearly something interesting is happening. Okay, so right, order of operations. Sorry, I just kind of dunced out there for a second. So 1 to the pi over 2 is just 1, and so what I have on top is minus 1, and on the bottom I have pi over 2, and so this is just minus 2 over pi. Okay, so that's the average rate of change of sine, and if you look at the picture, it kind of makes sense, right? It should be negative, because what am I doing? I'm going from pi over 2, which is like probably right here, over to pi, so it should be negative, and it happens to be that number. Alright, now for b, we just apply the formula again. So let me remind you what the formula is. There it is, right here. Okay, so here we go. So we're doing natural log of e squared plus e. Okay, oh sorry, I'm supposed to plug in the square root. So it's the square root of e squared plus e. Take away natural log of e, because the x thing has become 0. And on the bottom I'm just going to have the square root of e. And really I'm done. There's not too much you can do here. I mean, you can simplify this a little bit, so maybe that's worthwhile. Okay, so just a little simplification exercise. Don't have to do it, but it's kind of fun. So let's do, it comes out to natural log, square root squared is just e, right? And e with e is 2e. And I've got minus ln e. And down here I've got the square root of e. So something good happens here with the laws of logs. Can turn this into ln of 2 plus ln of e. So I just split this product into a sum, which is what log likes to do. Minus ln of e all over the square root of e. And look at this. These two things annihilate. And what we have left is ln of 2 over the square root of e. Okay, but we could have just left it the way it was at first. That's the average rate of change there, and let's look at the picture. We're going from 0 to the square root of e for this red thing, so here's 0, and whoa, the square root of e, I guess it's probably like around here, and so the line connecting those 2 points on the graph turns out to be that positive number, so that makes sense. Alright, and so maybe I should push this stuff down to do c. Alright, so here's c. Okay, so maybe I can do c in this color. So let me write the formula down again. F of b minus f of a divided by b minus a is the formula, right? So I just need to use it here. So what have I got? I've got e to the 7 minus e to the minus 7. Okay, so I just plugged in 7, and now I've got minus e to the 0 and quantity minus, so this becomes a plus e to the 0. And this is all over 7. So what have I ended up with here? These two things are both 1, right? That's 1, that's 1, this one's negative, the other one's positive. That means they kill each other. And so what I have left is e to the 7 minus e to the minus 7 all over 7, and I don't think there's any way to make that remotely nicer. So that's the answer. And great, problem 2 is done.